Let's now connect an ultrasound sensor. Take a 4-pin RMC wire. Plug one side of the wire to the connector on the dev board, which is marked as ultrasound. Plug the other side of the wire to the RMC connector on the ultrasound sensor. It is possible that the ultrasound sensor shipped in your kit does not have a 4-pin RMC connector. Instead it has a regular 4-pin header connector. In such a case, connect the other end of the RMC connector such that the first pin, which is either orange or red, goes to the pin marked VCC on the ultrasound. The last pin, which is typically black, goes to the ground pin of the sensor. On the dev board, locate the jumper selector marked as D6_select. Place the jumper plug such that the two pins on the right are shorted. On the dev board, D6 is used for both DHT and ultrasound. To allow switching between these, we have provided the jumper. If you prefer to use a breadboard or directly use a Node MCU, then the connections are: VCC of ultrasound goes to VIN of Node MCU, that is, 5 volts. Note that the ultrasound sensor requires 5 volts and will not work with 3.3 volts. Ultrasound sensor's ground goes to ground of Node MCU. Trigger pin of ultrasound goes to D8. Echo pin of ultrasound goes to D6. The ultrasound sensor works at 5 volts. However, the ESP8266 can only take 3.3 volts. So ideally a resistor voltage divider has to be used to reduce the echo voltage to 3.3 volts. Use the 68 kilo ohm and the 38 kilo ohm resistors provided in your kit, to build a resistor divider between the echo pin of the sensor, and ground. The 33 kilo ohm resistor will be the first leg and will be given to the echo pin. The 68 kilo ohm resistor will go to ground. The junction should go to D6 of Node MCU. That's it. Let's move on to the next step.